Good afternoon. Today we are going to learn a little bit about probability. So we're switching away from quadratics. We're running short on time. So I'm going to only assign two, well, which I normally assign, but theoretical probability, so JJ1, and outcomes of compound events, which is JJ3. First of all, theoretical probability. Let's talk a little bit about theoretical probability. Theoretical just means that it's well, it's theoretical. It's not. It's what we consider to be every event basically has the same possibility of an outcome. So again, in other words, theoretically, if we roll a six-sided dice, we have an even chance of landing on each side. Now, dice are not made perfectly. Sometimes actually people make what's called weighted dice, so it actually lands more often on one side than another. And so that's not theoretical probability. That's experimental probability where you roll a dice to kind of see, oh, is this a weighted dice or not? Theoretically means we're just going to assume that it has the exact same chance of landing on every single side. And then the way probability is stated is it's written like this, where P means I want to know what the probability is, and then in parentheses, it's what we want to know the probability of. So if we're rolling that six-sided dice, this statement says, what is the probability of rolling a 3? So the first thing we need to realize is what are the possible outcomes when we roll a six-sided dice. When we roll a six-sided dice, we can either roll a 1, a 2, a 3, a 4, a 5, or a 6. So the number of outcomes that, total number of outcomes that we can get from our experiment is our sample space. So our total outcomes is called our sample space. And then we talk about the number of successful events that happen. So we have 6 different events that could happen, or 6 different outcomes. Only one of them is a 3. And so probability is always found by the number of successful outcomes or successful events out of the number of total outcomes. So again, the probability of getting a 3 is just simply there's one chance out of a total 6. So we have a 1/6 chance of being successful. Now, if you'll notice these, whoops, I lost the thing there. It always says, well, this one says write it as a percentage, but it'll either say write as a fraction or as a whole number. The whole number, the only 2 whole numbers you could write would be 0 if there was a 0% chance, or a 1 if there's a 100% chance. You can't be larger than 1. Here's the probability of being heads. Now, again, we got to think about theoretically, it's either going to land on heads or tails. I know some of you are going to want to say, well, it could possibly land on that little flat edge. And so there is a small chance it might not even land on either of them. But theoretically, the coin's going to either fall over and be either a heads or a tails. And so there's only the 2 possibilities. They're an even probability of either happening. That would mean a 50% chance, right? A 1/2 or a 50% chance. So here's the one, simplify your answer, write it as a fraction or a whole number. Remember, the only 2 whole numbers you could possibly write would be either a 0 or a 1. So now here it's saying, what is the probability of a factor of 5? So we got to be careful and make sure we understand what the problem's asking. A factor of 5. Well, there's only 2 factors of 5. 1 in itself, 1 and 5. And so when we look at this dial, and it's cut into 3 equal things, so there's just as much chance of landing on the 5 as either of the other 2. So there would be a 1/3 chance, or 1 out of 3, of landing on a factor of 5. Now, if there had been a 1 here, a 1's also a factor of 5. So then there would have been a 2 out of 3, but there was only the 5. Sorry, what did I do? I put 1 out of 5. You know what I meant, 1 out of 3. I put 1 out of 5. So be careful when you type your answers in that you type them incorrectly. Here, again, you pick a card at random. So again, we're going to not know which card they are. We're going to cover them up. We're going to turn them over. And we want to know what the probability of getting a 4 is. Again, there's 4 total outcomes. And of those 4, 1 is a success. So 1 out of 4. This first lesson really should be fairly simple and easy. Again, Make sure you read carefully. Prime numbers, 3's prime, 5's number, 6 and 4 are not. So there's 2 out of the 4 total. 2 out of 4 reduces to 1/2, or 50%. And again, I think some of them will get like greater than 2. How many numbers are on a 6-sided dice that are greater than 2? Well, 3, 4, 5, and 6. There's 4 out of 6, which reduces to 2/3. I don't want to spend any more time on this one. Just make sure you read carefully and you realize that the probability for each event is just as likely as any other event, and you need the total number of events. The number 3 here, when I get to JJ3, outcome of compound events. Compound events basically mean we're doing 2 things simultaneously, or maybe 3, or maybe 4, and we want to know what's the probability of a combination of things happening. Probably the best way to do this is what's called, if you're struggling on learning this material, is to do what's called a tree diagram. A tree diagram means you take the 2 things that we're doing. We're spinning this spinner and we're picking a card. So we can either, when we spin the spinner, we can either get an L, a J, or a K. From there, we move to the next probability. And if you'll notice, there's only 3 things that can happen with the cards. So what I do is I go like, I branch out from each event happening in the first thing, or the spinner, to each event happening in the second thing. So I could get an F, a G, or an H. An F, a G, or an H, and an F, a G, or an H. This is called a tree diagram. And now it says you spin the spinner and pick a card. How many outcomes are possible? Well, we could either get the L or the F. We could get the L or the G, the L or the 6. So in other words, what we're doing is we're counting out down this right column here. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a total of 9 outcomes. Another way to think about it is what's called the fundamental counting principle. If there is 3 possible things on the first one and 3 possible on the next one, it's 3 times 3. You take the number of outcomes of the first event times the number of outcomes of the second event, and you get the number of total outcomes, which is 9. So here, you roll a die and spin the spinner. How many outcomes are possible? Well, there's a total of how many outcomes on spinning the dice? 6. How many outcomes on spinning the spinner? 2. What's 6 times 2? 12. We could take the time to do the 1, 2, 3, 4, 5, 6. That's supposed to be a 6. And then do the tree diagram, right? Each one of those outcomes on the dice can lead to one of 2 outcomes on the spinner, the D or the E. And again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's that 12. It's 2 times 6. So we do 12. Again, you pick a card, spin the spinner, and find the sum. Now, I want to talk about the difference between total outcomes and unique outcomes. Okay, so there's a difference. In this experiment, there is a total of 6 outcomes, because there's 3 outcomes. There's 3 outcomes from picking a card times 2 outcomes from spinning the spinner. That's a total of 6 outcomes, but they're not necessarily all unique, because it's talking about the sum of the numbers. So in other words, if I roll a 6, I could either spin a 2 or a 3, which would give me a sum of either an 8 or a 9. That's my sums. Now, if I spin a 7, again, if I pick a 7 card, not spin, if I pick a 7, I can still only spin either a 2 or a 3, but 7 and 2 add up to 9. I've duplicated 9. 7 and 3 gives me 10. Now, if I pick an 8 card, okay, I can still either spin a 2 or a 3. 8 plus 2 is 10. 8 plus 3 is 11. So I'm getting some duplication in my sums. So there isn't a total of 6 different sums, even though there's a total of 6 different possible scenarios or outcomes. There's actually only 1, 2, 3, 4 possible sums. So be very careful. The difference between the total number of outcomes, which is 6, and the unique outcomes. There's only 4 unique sums. So here again, it says you roll a die and spin the spinner. How many outcomes are possible? It's just talking the total number of outcomes. So I just know there's 6 possible scenarios for the dice. There's 4 possible scenarios for the spinner. 6 times 4 is 24. Here, you flip a coin and spin the spinner. How many outcomes are possible? Again, 2 possible outcomes on the dice. There looks like there's 6 possible outcomes on the spinner. 2 times 6, or for every one on the coin, there's 6 of these. So if I get a heads, I can get 6 possible outcomes. If I get a tails, I get 6 possible outcomes. That's a total of 12 outcomes, or 2 times 6. All right, here again, they're going to try to throw you. How many different sums are possible? So again, now you could take the time to do a tree diagram or actually try to think through this. I like that the numbers are consecutive. 1, 2, 3, 4, 5, 6. That's going to make it a little easier. On this spinner, there's a 6, 7, and 8. So the very smallest sum you could get would be a 1 plus a 6 or a 7. The very largest sum you could get, well, the largest number on this spinner is 6. The largest number on this spinner is 8. 6 plus 8 is 14. So the smallest sum would be 7. The largest sum would be 14. And I could get any sum in between. So I could get an 8, a 9, a 10, an 11, a 12, a 13. So again, I got 1, 2, 3, 4, 5, 6, 7, 8. 6, 7, 8. So 8 possible sums that I could get, even though if I take 6 times 3, because there's 6 possible outcomes on the first spinner, 3 possible outcomes on the second spinner, that's 18. There's 18 total outcomes, but only, what did we say there was? 8 unique ones. 1, 2, 3, 4, 5, 6, 7, 8. I've counted that now like 5 times. So there's 8 unique outcomes because the smallest sum was 7, the largest sum was 14, and we can get everything in between. But that's only true because these are all consecutive. It would probably be a little easier or a little more precise if you did a tree diagram if the numbers weren't consecutive. You flip each coin. How many outcomes are possible? So now be careful here. You flip, one's a penny and one's a nickel. So yeah, so how many outcomes are possible? There's 2 possible outcomes on the penny. There's 2 possible outcomes on the nickel. So there would be a total of 4. Heads on the first coin and tails on the second coin, right? So you could get, again, a heads and a heads. You could get a heads on the first coin and then a tails. You could get a tails and then a heads, or you could get a tails and then a tails. Now, those coins are distinct. One's a nickel, one's a penny. If they were the same, it might be a little different because you know which one was the first one or the second one if they were both pennies? Maybe not. Here, you roll a die, spin the spinner, and flip a coin. How many outcomes? Again, total outcomes. This is just that simple, what they call the fundamental counting principle. How many possible outcomes are there on rolling the dice? 6. How many possible outcomes on spinning the spinner? 2. How many outcomes on flipping the nickel? 2. We multiply those together. 6 times 2 times 2 is 24 total possible outcomes. Again, we could take the time to do 1, 2, 3, 4, 5, 6, and then break off and do the C and the D, and then break off the C and the D and do the heads or the tails. But again, for each one of these, there's going to be 2 outcomes, and there was 6 of these. So 6 times 2. Oh no, and so for each one of these, there's 6 outcomes. For each one of these, there's 2. So there's 2 times 6 is 12, and then there's 6 of those. 2 times, I keep messing up my numbers, don't I? There's 2 for each one of these, and how many of these are there? There's 12 of them, because there's 2 for each one of these. So there's 12 of these, and each one of these has 2 outcomes. 12 times 2 is 24. So again, the tree diagram is very long, so I would try to just remember that fundamental counting principle and multiply. If you have any further questions, please do log on or email me and ask me questions, and I will help you any way I can.